write that, and so they built an object. So what we're going to do is look a little bit under the covers of what it takes to build some of these objects. And so if we think of this program that originally just sort of did processing, we can think of it as having some kind of an input, right, coming into our program. And we have a string object, a dictionary object, maybe eventually some objects like a database object or an object that we eventually define. And you can think of as we're receiving data, it comes in an object, which is a string object, where we start putting the strings in dictionaries and do whatever. We pull out a list of them. And so you can think of data as moving between these objects. And like I say, even strings in the first week, first lecture, first week, first everything, we were using objects, and we've been using them all along. And so you can think of every string and every dictionary as a little program all by itself that has a bit of code and a bit of data. And so a string has the data, which includes all the characters that make up the string, but then there is a method called upper that does uppercase, or rstrip that strips off the right, a white space from the right. And so it's like they're almost little programs that have inputs and outputs themselves, and we can make lots of them. And there's lots of cooperating objects that make up an application. And one of the nice things about the object-oriented pattern is that they form boundaries, and within the boundary, if you're inside the object, you can say, look, I'm going to build you a string object or a database object or a beautiful soup object, and I'm going to build this capability, and I'm going to give it to you in the form of an interface, and I'm not really going to care how you use it. And so we have this sort of visibility wall where I'm going to make an object and I'm going to let you use it, and the maker of the object doesn't necessarily have to know every single thing about the use of that object. But so just like inside the object, they don't have to worry about what you're doing with the object outside of it. When you're outside the object, you don't have to worry about what's going on inside of it. We, as the user of the object, we talk to its interface and we get things from it and give things to it and use functionality within that object, but we don't have to look inside of this. We can just say, oh, it's a nice little magical thing. We read the documentation, we read a web page, and it told us to do this, this, and this, and away you go. And so it is sort of this isolation boundary that works both for the programmer who's writing the object and the programmer who's using the object. And so it's a very nice pattern, and so you'll see how we're going to build code and we're going to group it together, and then we're going to be using it sort of as a big blob of stuff. So some definitions in this space, words that I want you to understand. When we're going to create one of these things, one of these objects, instances, that has some data in it and some code in it, we have to be able to define the shape of this object. What code will each object have in it, and what data will each object have in it? And that's called a class. The key to a class, and this little picture that I've got up here in all these slides, is a key. The class is a template. It's not the thing itself. So it's a cookie cutter. It knows a lot about how cookies are made. And if you have cookie dough and you hit the thing, then you make as many cookies as you want. And so this nice little cookie picture is a great, mental model of how it works. The class is the template, and then the object are all of the cookies that are made from that template. But the template defines the shape and the nature of the class. So the code that we write is going of each of the objects. The code we write is the class code, and then later we say, oh, let's take that template and make ourselves an object or an instance. Now, as we're defining a class, we have two basic things that we put in the class, and there's a couple of different terminologies for this. One is method, which is code. It's like a function that lives inside of a class. Not a function that lives inside your program, but one that lives inside of a class. And so this is a scoping thing. A method is really just a function, but it lives inside the class. And then fields or attributes are data items that are in the class. And so they're variables that are defined in the class. You can define variables outside the class that you use in your program, and you've been doing that all along. But if you're saying, I'm going to build this capability, and it's going to have data inside of it and code inside of it, the code is the method or message, and field or attribute. And there are just two different sets of terminology. Method is what I'll probably use. If you look in some object-oriented patterns like Smalltalk or Apple they often will call these messages. So you can either like access a method inside of a class or an object, or you can send a message to the object. The same is true for field and attribute. It's just a chunk of data that's in the object that you may or may not have the right to access. So, like I said, a class is a template. It defines the characteristics of the objects that we're going to use to make it. It is the cookie cutter. So, dog is sort of the exemplar. Lassie is a particular dog, and so dog has fur, and dog barks, and dogs do all these things, and so we know something about dogs, but it doesn't mean we have a dog, right? The class is a more abstract concept that when it's time to get a dog, we know certain things about dogs. Instances, or objects, are once we say, oh, time to make a cookie from the template, time to get a dog, we know something about dogs. That's the creation of an object, and that we call them instances, instance of a class. So the class is it doesn't exist, but we say, make me a new object using this class as its template. Oh, and now make me another one. And so we can have many, many objects from one class. So just like many cookies from one cookie cutter. Method is a bit of code that lives inside of an object. It's like a function, but it's scoped to within the object or within the class. Okay, so that kind of gets us started on some of the terminology, and we'll come back and we'll take a look at how we write code that's object-oriented. Okay, so now that we've gotten through the definitions, let's work into some sample code. But hey, look at this. We've got ourselves a cookie cutter and some cookies. So remember that a class is a template. It's not the actual thing. An object is an instance of a class. So you have to take the class and do something to make the object. And actually you can see here's some other classes. There's clearly a sort of a snowflake class and a gingerbread man class. That's an object, object, object. Somewhere out here there is a snowflake class and a gingerbread class. But we got a snowman object and a snowman object and a snowman class. So class is the template. Object is the instance. So here's a bit of Python code. So let's take a look at what we got here. Class is a new reserved word, kind of like def. We have the name of the class. That is a name that we choose. That's the name by which we'll refer to this class for the rest of this program. And it has a colon at the end of it, and which means it starts an indented block, which ends when we de-indent. Inside the class, there are generally two things. There is some data, and this just looks like an assignment statement in the class, x equals 0. And then there is a def. This looks just like a function, and then it starts with a def, has a colon, indents, so that function finishes right there. The difference is this is a method because it lives inside of a class. And so there is no function called party. There's a function called party within party animal class. And we'll talk in a second about this self thing. It is the way that inside this code we refer back to that variable. So this is not actually executing any code. It's sort of remembering the template, defining the class party animal. This is what we call constructing. We're constructing using the party animal template or class. We are making a party animal, and then once we make that, we stick it in the variable an, and then we're going to call this party animal, this party method 3 times, 1, 2, 3. Now this self thing, and we'll take a look at the self ends up being an alias of an. And so you can look at this syntax as just kind of an equivalent of this syntax. It's calling the party method within the party animal class and passing the instance in as the first parameter. And so self ends up being an alias of an each time these are called. Now if we make a different variable and a second object, which we will eventually, you will see that works a little bit differently. And so this syntax is a short version of that syntax. So if we watch how this executes, it starts up here, it just defines it, and then we construct it. And that's what basically constructing it. We know how to construct it because we look at the class and we make a variable x, we make some code party, and then we construct that. That's what the party animal does, and then we assign that into an. And so an is now pointing at that. Then when we call the party method, that basically takes this AN and passes